Hello guys, welcome back to laptop repair case study. So today we got a laptop for repair. So we received only the motherboard. So this is an Acer laptop. So you can see the part number is 12253-3M. So this is Wistron production. So this is Wistron production for Acer laptop. So Acer brand. Okay, the problem with this laptop, it doesn't turn on. So it's a no power case. So we diagnose the problem and try to find a solution for the laptop. Okay, so let me physically inspect whether we have anything visible. So everything looks fine on this area. What about here? Okay. What's this one? It looks like a dirt something. It's like a grease or something. What happened to this board? Something has spread all over the area. I don't know. Anyway, there's no components on this area, so we don't need to worry about that. We can clean that later. Okay, nothing much going on this side. This motherboard looks so huge. There's not much components going in this motherboard, but this motherboard is very large. You see, it's larger than the normal one. Okay, anyway, so let me connect the adapter to see if there is any reading on the DC power supply. Okay, yes, it's taking around no ampere, so it took around 30 milliamps, then back to 0. Okay, let me press the power button just to see. It's taking around 10 milliamps and it is fluctuating, and it's staying at 10, so 10 milliamps, that's it. Okay. So let me see what are the voltages present in the motherboard right now. I'll just press the power button. Okay, so this is the core coil, so this won't be generated right now, so we need to check the always voltages. So 5 volt and 3 volt, like that. So this is 0.9 volt. Okay, that is present. So this looks like 5 volt and 3 volt. So this one looks like 5 volt and 3 volt, but we don't have any voltage there. I'm pressing the power button, no voltage. So what about this one? Either one of these should be the RAM regulator coil. So RAM coil it should be. So we are not getting any voltage there. Wait a second. Some voltage is coming on this coil. 0.3 volt. What's that? .4 volts. Okay, and you can see the LED is glowing, which is a power LED that is glowing. So something is happening in the board. So if I disconnect the adapter and connect again, what does it says? Yes, it's glowing. If I press the power button, no, nothing, no reactions. Okay, fine. So let us start our checkup. First we can check the inductors. So upper and lower MOSFET we need to check. I need to find a common point to start with. So where is the common point? So if you look here, we have the DC jack, and the traces follows through this way to the first MOSFET, then through a big trace it going to the second MOSFET, and then we have the common point is here, which is the CSR. Then it goes to this point here through a resistor. So we have 3 CSRs here. So 3 current sense resistors in this motherboard. So sometime this motherboard may be narrow voltage technology, which means the common point will be after the charging section, after the upper MOSFET of the charging section. Then it will, from that point it will be distributed to entire motherboard. So that is called the narrow voltage technology. If it is a hyper boost technology, then after the second MOSFET, from this point, if the voltage is distributed all over the motherboard from this point, then it is a hyper boost technology. Okay, so we can find that in a moment. So let's start checking that. Yes, 473, okay. Yes, 514, 497. Actually, this is not a narrow voltage technology. This is hyper boost technology, because we are having a communication, which means the diode value is correct from the first current sense resistor, which is on the after the second MOSFET. Okay. Here 402, 500, okay. 500, okay. This motherboard is too big. My camera could not capture everything. Okay. 900, okay. 500, okay. Yes, so this is the battery current sense resistor. So if I probe one of the probe in this point, negative probe, and if I keep on the CPU core coil, so there's a reading, okay, 590, okay, no problem. So on this side here we have 1.3, which is more resistance. Yes, so all other areas having high resistance. So actually this point is not directly connected to the upper MOSFET of these points here. Only the current sense resistor after the second MOSFET is directly connected to the upper MOSFET to this point here. So that's why we are reading 0.5 at this point. Okay, so let me check the lower MOSFET as well. $130 CPU coil, okay. 66, okay. 380 okay, 383 okay, 400 okay, 400 okay. Right, so there's no much short in this motherboard, so there's no short in this motherboard. So this looks like a little bit lower, but anyway, that's okay, I think. Yeah, it's okay. So maybe this is an auxiliary voltage for the CPU, so because of that it might be lower. All right. Okay, now where can we start from? The question is, where can we start from? So already we have 5 volt and 3 volt LDO voltages, because the power button signal, when we press the trigger button, so we have a response. So if we have only the LDO voltages on this motherboard, the power button trigger will be take place. Okay, then we can start from the EC chip. What is the name of the EC chip? U2401. Okay. So do we have an EC reset for this EC? So this is an ITE brand. If you look here, this is an ITE brand EC chip. So the model number is IT8587E. So I think this also has an inbuilt BIOS chip in this motherboard, in this EC chip. Okay. Let me see whether we have the EC reset. Yes, we have the EC reset signal on pin number 14. Okay. So we should find 3.3 volt on pin number 14 once we connect the adapter. So we have 3.3 volt at pin number 14. So the EC reset is okay. Right. So the next signal, we need to find the AC in signal, which is sent by charger IC once it detected the AC in, which is the adapter detection signal sent to EC chip by the charger IC. We need to check on pin number 120 whether we have 3.3 volt. I'm sorry, actually I measured the wrong pin before. So here's the pin number 1. So as an anti-clockwise, so it should start from left to right, so this way. So it is on pin number 14 is on this side here, and we have 3.2 volt on the EC resets. That is fine. Okay. So on pin number 120, we don't have any voltages. AC in signal. Okay, let me see it again. No low impedance also. We should check that. So only if the EC chip receives this AC in signal, then only it will release the S5 on signal to the motherboard to release to the standby IC to release the 5 volt and 3 volt coil output. Okay, so let us trace the signal from AC in back to the charger IC. Wait a second. Actually, we should have a voltage on the AC in pin, because the AC in pin is connected to the pull-up resistor, which is 3.3 volt LDO voltages. So the LDO voltages is present in the motherboard. So why we are not getting AC in? Pin number 120. Let me check once again. No, we don't have any voltage. Yeah, I'm probing it correctly. No voltages. Okay. If I press the power button also, we have voltage. Okay. So if I press the power button, we are getting 3.3 volt. That is fine. Okay. Yes, so if I press the power button, did you see the board is turning on? Okay. Board has turned on. And the current is drawing about 200 milliamps. Actually, the board has turned on, I think, so it's shut down again. Okay, I'll just show you on the DC power supply the current intake. Wait a second. I think the problem is on this section only. So just a simple problem. Okay, let me see that. Let me press the power button again. No, this time it's not turning on. Yeah, it's turned on. Okay. You see the current drawing around 270 milliamps. And the board is spinning. Okay. So we should have all the voltages right now. So 3.3 volt is present. And 5 volt is also should be there. Let me press the power button again. No, this time it's not. Okay. So is it a dry soldering on this area? On the AC in pin? So when I touch on the AC in pin, the board has turned on. Yes, the board is spinning. Okay, I can understand this situation. So when I get the AC in signal 3.3 volt, the board is turning on when I press the power button. So when I press the power button, if I don't get the AC in signal to the EC chip 3.3 volt, the board is not turning on. Okay. Yes. So we need to find the AC in signal from the charger IC and also the AC in circuit. There's a small circuit that brings the AC in signal to the EC chip. So we need to check that as well. Now I'm pressing the power button, the board is not turning on, and also if you see on the multimeter, there is no voltage on the AC in pin. Okay. Right. Okay, so this is the schematics of this motherboard. So according to the requirement of the charger IC, so on pin number 5, it should send a low logic on pin number 5 if it detects the adapter voltage, or if it detects the adapter. Because if you see here on pin number 5, they have marked as hash, which means always the hash mean active low signal. So when AC OK is validated, so the charger IC will send low logic at pin number 5. So we should get low voltage or low impedance on pin number 5, and also we should get low impedance on pin number 120 of the EC chip. So we need to check that one. So while we were checking, we had high kilo ohms. So let me check again. So sometime I may have checked the wrong pin. So let me check again on 120. Okay. And after that we need to check the S5 signal sent by the EC chip to the standby IC also. We need to find that. Where is it? Oh, okay, so this is on pin number 19. So on pin number 19 we need to check S5 enable either before or after pressing the power button. So this is S5 enable, goes to the EC chip, goes to the standby IC sent by the EC chip in order to release the 5 volt and 3 volt inductor voltages. Okay, let us check that one. So first we need to check AC in signal, so it should be low on 120, so we can see that with the ohms value. And also on pin number 19 it should be 3.3 volt either before or after pressing the power button. Okay, so this is the charger IC, which is BQ24727. So on pin number 5, this is 1 2 3 4 5. On pin number 5 we should find a low logic, and also on pin number 120 of the EC chip, which is on this point here, we should find a low logic at this point as well. Okay, let me check that. First I can check from the charger IC. Now the adapter is connected. Let me check it. Yes, it's sending low logic, which is 23 ohms or something. Yeah, 29 ohms. So the adapter detection is validated and it is sending the correct low logic to the EC chip. So let me check on the EC chip as well. Yes, so this one is 19, so we are reading 0 ohms. So we don't have any voltage on that pin, and also the ohms value is 0, which means so the EC chip is not sending the S5 enable signal to the standby IC. So let me press the power button and see whether we have any voltage there. The power button cable was disconnected. Let me connect it again. Okay. Yeah, this is pin number 19, I'm sure. So we are getting 0 volt, so that's why we are not having 5 volt and 3 volt output, and also the board is not turning on. So this is the which is similar to the one that we saw earlier in our case studies, the gun type HP motherboard, which the EC chip was not sending the S5 enable signal. So as a result, the 5 volt and 3 volt inductor voltage was not released. So I think this one is also similar to that one. Anyway, we will see that. Okay. So what can we do now? So even after pressing the power button, we are not getting S5 enable signal, isn't it? Yes. Now let me go directly to the standby IC, and also we can check on that one as well. So here we have the standby IC, which is PU4501, and this is Texas Instrument, I think. Yes, TPS 511 Yes, I think, yeah. Okay, now let me check the schematics. So on which pin number it receives the enable signal. Okay, so we can check on pin number 6 and pin number 20 of the standby IC to see whether we have the enable signals for the 5 volt and 3 volt output. Okay. So 6 is on this side Do we have a voltage? No, we don't have any voltage there. Okay. And on pin number 20, so the signal is connected to the same point. No voltage. Okay. And we have 11 kilo ohms. Okay. So we need to find a 3.3 volt LDO. So I'll check here whether we have a 3.3 volt LDO in any capacitors. So this is 5 volt. Where is 3.3 volt? Yes, here we have a 3.3 volt. Okay. So we can jump from this point to the enable signal of the coil voltages. So and see whether we have the 5 volt and 3 volt output. Okay. Okay, before checking that one, we need to confirm whether the EC chip is releasing the RSM reset signal, because it is crucial to know that the BIOS region inside the EC chip is okay. So only if the BIOS region inside the EC chip is okay, it will send the RSM reset signal output. So if you don't have an RSM reset signal output, so there is no point of just jumping 5 volt and 3 volt coil voltage enable signal with an LDO voltages, because the problem is on the BIOS region of the EC chip. So first we need to confirm that whether we have the 3.3 volt on the RSM reset signal. Okay, so I'll find that. Yes, the RSM reset is on pin number 112. So let me check on pin number 112, either before or after pressing the power button, whether we have a voltage. So this is pin number 112. Now we are having 11 ohms. So let me press the power button and check. Yes, we have 3.2 volts. So the RSM reset is released from the EC chip. So we are fine with that. So now we can go and jump the S5 enable signal with the LDO voltages. So it's very important to check RSM reset signal before doing any of these types of jumper works. Okay, so where do we going to jumper this one? So we cannot jumper straightly on the pins of the chip. Okay, so here we have the R3619. So on one side, on this side here we have S5 enable coming from the EC chip, and also on the other side this is connected to the hardware shutdown circuit and also to the 3 volt and 5 volt enable signal. So I just want to show you something. So first, now I have disconnected the adapter and I am going to connect the adapter and see on the input side of the resistor. Before pressing the power button, we are getting 45 ohms. So actually it is working correctly, but if I press the power button, the low impedance is rising to high impedance. Okay, but if I shift to voltage, there is no voltage. Actually this voltage is not enough. We should have a voltage around 3.3 volt. Then only the standby IC will recognize that the 5 volt and 3 volt enable signal is received. When you look at this circuit, you can see it is written as hardware shutdown, which is pure hardware shutdowns. So it will be sent from a thermal circuit maybe. So when there is a low logic at this pin here near the diode, so the direction of the diode is on this way. So anode will pass through this way. From this way, negative voltage can pass through or the ground can pass through. So when there is a hardware shutdown went to ground, so it will pass through this diode and it will reach to this here to the standby IC, and 3 volt and 5 volt will be turned off, so they will turned off. And also it will go to this section also, to the EC chip, but it is having a 2 kilo ohm resistor, therefore the ground will not pass after this resistor, so it will stay on this point here. So this S5 enable signal is rising to high logic, but there is no voltage at this pin, so that's why we are not getting the 5 volt and 3 volt enable signal for the regulator IC to turn on those 5 volt and 3 volt. So we are going to give an alternative 3.3 volt at this point in order to turn on the regulator to release the 5 volt and 3 volt. So what we can do now, so we can place 3.3 volt, just connect a wire from the 3.3 volt line, then we can join at this place here. So we don't have resistor at this place, we can join it here, so we will be having 3.3 volt everywhere in this circuit. And also it will go and turn on the 5 volt and 3 volt inductor voltages at the standby section. So we can just jump 3.3 volt on R3618. If you want, we can just remove R3619, so we don't need this resistor hereafter. So if this resistor interferes this voltage 3.3 volt, we can remove this as well. So we'll just try to connect it here and see whether the 5 volt and 3 volt is generating. Okay, so I'm going to jump from this place. So 3618 is a lower resistor which is on the hardware shutdown circuit, so I'm going to jump from this place. So I'm not going to touch the R3619 because it's not appropriate to remove and connect voltage on that point because it is directly connected to the hardware shutdown circuit. So in case if it sends low logic, so there will be a problem on the 3 volt LDO line. So for that purpose, I'm going to connect the R3618 with the 3.3 volt, and here on this side, on this pin of this diode, so here we have a 3.3 volt, so which is an LDO voltage, so it will be easy for us to jump. Okay, I'll just connect the adapter. Yes, here we have 3.3 volt. So I'm going to jump from this place to here in this resistor. So I'm not going to connect a jumper wire from this point to this resistor here. So I'm going to connect another resistor in this place, and I'm going to connect the jumper wire after this resistor in this place. So because this line is meant to be low logic when there is a problem on the thermal circuit and also any components failure. So in that case, this will be low logic. So in order to protect the LDO voltages, I need to place a resistor in this place, like 20k is enough, I think. Yeah, 20k is enough. Even 100k is okay. So I can place a resistor on this place and connect a wire from the resistor back to this point. So which will be a protection from causing some other inconvenience to the motherboard. Okay, I just took a 10 kilo ohm resistor. So here I have that. I'm going to place it on this side here. Only one side of the resistor is touching this one. Okay, fine. Or else I can turn this side, it will be easy. Okay. Okay, now it's perfect. I can also jump on the other side. Okay, it looks fine. Let me tear this. Okay. So I'm sure it should work. Anyway, it's just a trial and error method. Let's see whether we have the 5 volt and 3 volt output. Okay, I'm going to connect the adapter. Yes, the adapter is connected. The ampere reading is very low. I think the coil voltage is not generated. Okay, anyway, let's check. No, it's not generated. Okay, let me press the power button. No, still not generated. Okay, let me go to the jumper that we did and check it. So it's under the heatsink. I have to remove that. Okay, so here we have 1.8 volt. So yes, now the board has turned on. Actually, the 10 kilo ohm resistor is not appropriate in this place. We need to increase the resistance because the voltage on the other side has decreased to 1.8 volt. So we should have 3.2 volt, but the voltage has decreased. So it should not be like that. Okay, right. So okay, wait a minute. So this D306 is the diode that is connected to the pure hardware shutdown. So that is the 3.3 volt that we saw at that time. Okay, so actually we can't connect at this point, so we need to find some other place to give the 3.3 volt at this point. Okay, let me see. 3.1 U702 U702. What is it doing? U702. No, it's U701. Wait a second. U702. Yes, U702. We can find that. So on U702, on pin number 2, so we have to jump on this place here. So here we should have, yeah, we have 3.1 volt. So we need to jump from this place to this place here. Okay, let me see that. Let me check whether we have voltage on these jumpers. Yeah, 3 volt. This is appropriate. Okay, 3 volt. And on this side here we have 3 volt. On the output side 5.19. okay, let me press the power button. Actually the light is blinking. It is not continuously glowing, it's blinking a little bit. Okay, let me see whether we have the output voltage. No 5 volt or 3 volt. No, we don't have. Okay, so what shall we do now? So I'm in a situation. Okay, we don't have enough voltage on the output side. Still we have 522. Okay, so what about on the other side? Do we have any voltage? On this pin here on R3619? No, we don't have voltage on the R3619 on the outputs, on the input side. So let me press the power button to get a high impedance. So we have 700, yeah, 700. And now the board has turned on, you see, and it is turned off. Okay, now I'm going to remove this resistor from this place. We don't need this one actually. Which is R3619. So which is responsible for receiving the signal from the EC chip. So we don't need the EC chip hereafter, so I'm going to remove this resistor from this place. Okay, that's enough. Let me cool down the board a little bit. Okay, let me reconnect it. Yes, it's 2 milliampere. If I press the power button, what do we get? Nothing. Yeah, now the board has turned on. Okay. Let me see the voltage quickly. 500 on this side. We have 3.1 volt. Okay. Now we got 3.1 volt on this side. That's appropriate. Okay. Let me trigger it again. Whether yes, now the board is turning on normally. Okay. Right. Now I'll just try to connect the heatsink. I'll connect the fan as well, so that we can see that. All right. Okay, now I'm going to press the power button. Yes, now the board is turning on properly. You see this one? You see the ampere, it's taking around 200 milliamps. Let's wait for a second and see whether the board is turning off. Yes, it's taking 300 milliamps. Very good. Yes, now the board is staying still, so it is not turning off. Okay, now let me connect the RAM module so that I can check whether there's a display. So this is a DDR3 RAM or 3L RAM. So it's a DDR3 RAM. Okay, so it works in 1.5 volt. Yes, now the board is turning on smoothly. Yes. Okay, now let me connect the mouse to see whether we are getting a display. Yes, we got the display. You see, we got the display. So we have solved the problem. So this is just a simple solution. So just jumpering the S5 enable signal from the EC chip. So most of the time when the EC chip becomes faulty, this will happen. So we need to find some other solutions. Okay, actually I don't like this work. It's visible that I have done something here. So I'm going to try to reconnect to the place that I jumped earlier. So I have removed this one here. Okay. So I don't like this jumper. I'm going to try to connect from this place, from the other side of the diode and to the resistor, so that it will not be visible that we have worked here. Alright, so I'll just clean this one as well. It looks a bit dirty. Yes, now it has turned on. Now let me check the voltage on the SY enable that we did. So there should be enough voltage, because if there is a voltage less than 2 volt, or it's under the heatsink. Anyway, I can check on the other side as well. On this point here, yeah, it's here, this one. Let me check the voltage. Yes, 3.2 volt. It's good, there's no problem with that. So it's enough voltage. So that is okay. So there won't be any problem. So actually there's a problem on the EC chip. You see, still now we are getting just a 0.8 volt. So the EC chip is actually it's turning on from the low impedance to high impedance. It is switching from the low impedance to high impedance, but it is not sending enough voltage. It's just a 0.8 volt. Actually we should have 3.2 volt. So then only we will have the LDO, the coil voltage output. Okay, so still now the board is running. Let me check whether the display is executed once again. Yes, now the display is executed. Okay, so we have solved another motherboard. So I hope this might help you guys. So stay tuned to get another video with you. So thanks for watching.